Hello and welcome to an overview of the Core platform and the Core Bot Builder. To access the Bot Builder, go to developer.kore.ai and click on the Bot Builder icon on the top right corner. The Core Bot Builder is the web-based IDE that you can use to design, develop, and deploy bots on the Core platform. Once you're in the Bot Builder, you will see the bots that you've developed or the ones that have been developed by other developers and shared with you. You can start out by creating a brand new bot called a standard bot, or create a universal bot that uses multiple bots as part of a single bot configuration. Once you're in a bot configuration, you will notice that you're first taken to the task for your bot. The tasks represent the functional behavior of a bot. In this example, it's a banking bot. This banking bot has several tasks related to banking functionality, such as checking account balances, making payments, etc. In addition to the dialogue task, you also have knowledge task. A knowledge task is used when you want the bot to be able to answer questions to frequently asked questions. You have the ability to import these questions and train the bot to be able to answer these questions without having to do any lookups to the backend system. The next task is an alert task. An alert task is used when you want the bot to proactively engage the user into a conversation based on either a user-defined event like a new bill alert or even an enterprise-defined alert that the enterprise wants to define. The next task is an information task. The information task basically allows the user in natural language to ask or seek information from the backend systems. For example, I could search for my transactions by asking, show me all my transactions for my trip to Spain that were related to food. And the platform will take the natural language input, convert that into an information query to the backend and come back with a response. We give you the ability to actually summarize this information, at the same time present the information using various UI elements interspersed with the conversation. The last one is an action task. An action task is a slot filling task. In this example, it could be reporting your card lost or stolen, and in order to perform that action, the bot may ask some specific questions or slots to fill, and then once those slots are filled, it'll go perform the action such as reporting the card lost or stolen. Let's start with the dialogue task first. Let's pick the make a payment dialogue. Once you open the dialogue task, what you will see is the dialogue builder. This is a complete visual drag and drop environment for you to describe the conversation flow that you want the user to have with the bot. Now, assuming the intent is recognized, which is the starting point to any dialogue, the dialogue will follow these steps as a way to execute from start to finish. Each of these nodes that you see in front of you have various properties that you can set. In this example, it's an intent node which has intent-related properties that you may provide. Similarly, if there was an entity node like this one, you will have various entity-related properties that you can configure as well. For example, the platform provides a rich set of entities that you can configure for the natural language engine to recognize various forms of inputs, which is entity data that the user may provide in natural language. In this example, it's a date entity. So a user may say, I want to make a payment today, on Friday, next Monday, last day of the month, which are various natural language ways of expressing a date, which the platform will recognize and convert that into a real date that it can push into a system. Similarly, we have various other entity types that are useful for large enterprises, such as custom entities, composite entities, entities that are dynamically looked up based on the set of accounts that this particular user has, etc. These are very useful to design an experience that is rich and able to handle all the different forms of input that the user might have. Similarly, we also have something called a service node. In the case of a service node, you may actually make an API call by providing various auth configuration details to support the API request, various headers that you may pass on, and of course you can actually test the API call right from within the bot builder to make sure you're getting the right data back from this particular API. You can also provide script load for you to write business logic, such as preparing a payee list or maybe validating your data before you make a payment. And then you have confirmation nodes which allow you to validate whether the user would like to proceed the payment or not. And assuming the user agrees, you can finish the transaction by making another API call and then presenting a message to the user. Now, the message node is showing you that you can provide any message to the user based on various capabilities that the platform provides. For example, I can actually provide a message in simple plain text and various parameters that I want to apply to the message, such as addressing the user by the first name or a transaction ID that I received from the backend or other details about this particular transaction. Now, I can also make this message as complex as I want to by writing JavaScript logic and dynamically generating the message based on various data points that I'm getting back from the API call. These messages can also be designed by channel. Notice that this is the message I have for all channels, whereas I have a specific message for my web and mobile channels, and I have a specific message for SMS, and I have a completely different message for Facebook. The platform allows you to optimize the messages sent back to the user by channel in order for you to take advantage of the capabilities that each channel has to offer. You can also provide multiple messages for the same channel as a way to randomize the message, and the platform will present a different message each time to the user. Now, let's actually test this dialog right from within the bot builder as well. In order to do that, you can actually invoke the talk to the bot capability here, which allows you to test this dialog that you've just built. You can actually also monitor the conversation using this debug panel as the conversation is actually being executed. For example, let's type in something like, I want to make a payment. When you execute the dialog, in this case, I'm providing the utterance which is mapping to this particular intent, which is the make a payment intent. Now, because I did not provide any entities, the dialog is actually going to follow the path that I've laid out in this particular design by the developer. So it's going to first ask me for the account. Let's say I pick the checking account. How much do I want to pay? Let's actually make it verbose. I want to pay $50.12. When do you want to pay? Let's pay on Friday. Who do you want to pay? Amazon. Now, notice on the left side, the dialog is being tracked in the debug panel as it's going through its execution steps, like a typical debug log. Similarly, I also have a natural language analysis tab which allows me to actually see the scoring that the engine produced to match it to this particular intent, which is the make a payment intent. I can actually also see the sentiment of the dialogue from the user point of view, both at a message level or at a dialogue level. And then finally, I can actually look at the context data that's also being tracked at any given point. For example, I have provided various entity information so far, such as the account I picked for the payment, the amount I want to pay, the date I want to pay in actual date, and the payee that I want to make the payment to. Similarly, there is other context data that is also being tracked by the platform at any given point. For example, any API calls that have been made by the platform through the course of the dialogue, the entire API information and the payload returned by the system is available. Also, there are various contextual objects that are being populated as well, such as enterprise context, bot context, user context, and the session context for this particular session, both at the user session level as well as the bot session level. This context data is extremely useful for the bot to constantly leverage information that the user has already provided. Now let's test and invoke the same dialogue with a more verbose utterance. For example, if I were to say, I want to make a payment tomorrow for $70.34 from my checking account, let's see how the dialogue executes. In this case, I actually provided not just the intent, but several pieces of information that are already required or necessary for the payment transaction to happen. So notice that the platform automatically picked up all the information that I gave in my utterance. For example, the account I want to pay from, the amount, the date. The only thing missing, which is what the platform is going to ask for, is who do I want to pay. Let's say I want to pay to Amazon, and now the dialogue will continue onwards. So again, the platform is very flexible for you to design the conversation in a way that if the user did not provide any information, the platform will follow the path that you've designed. But at the same time, if the user provided various entity information, it will actually pick that information from the utterance and skip those steps and questions and then only ask for information that it doesn't have. Now that's a dialogue task. Similarly, we have other task types, for example, the knowledge collection. The knowledge collection is used when you want to enable the platform to be able to respond to various questions that the user might ask that for which the knowledge is already provided to the bot in the form of a knowledge task. The way to do that is we have the ability to actually import knowledge from your systems of record or your content repositories into the core platform. This particular knowledge import is done in two ways, using either CSV imports or JSON imports. Once you import the knowledge in the form of a question and a response, there are two other things that you can do. One is you can actually provide various alternative utterances for those questions so that the natural language engine has the ability to actually recognize the user's utterance, map it to your question, and then provide the response. Similarly, you can actually provide an ontology which represents the structure of your business and how these questions are organized by the ontology structure as well. For example, if I actually pick a particular leaf in this ontology tree, I have various questions associated to, for example, making a payment or how do I pay my bill. Similarly, I have other questions related to viewing bill, first charges on a bill, etc. This allows you to actually take your ontology structure and then organize all the FAQs against the ontology structure that represents your business. It significantly helps the natural language engine to recognize the questions that the user is asking, mapping it to the ontology tree, as well as the specific question within the ontology structure. We also have an alert task which allows you to quickly configure an alert which the user can set up or the enterprise can set up based on various parameters that the user might be interested in. Similarly, we have information task, which is a similar configuration like the alert task, where you can represent the API call that you're going to make, as well as the parameters that you need to be able to actually call the information task. And lastly, the action task is also a similar configuration like the information and the alert task. Now, once these tasks are defined, the next step in the SDLC cycle is to now provide the natural language training. Because the core platform offers multiple natural language engines, you would provide training data to each of those engines to be able to do an accurate job of identifying the intents as well as the entities. For example, for the machine learning model, you would provide utterances for various intents that you've defined so that the deep neural network based ML model will accurately take an utterance, score it, and then map it to an intent that you've defined here. One of the unique things we offer is not just the ability to actually provide these utterances which you can import as well, You can actually also visualize the model that you define in order to actually identify how good is your training. For example, if when you provide training data to an intent like get account balance, we actually at design time show you how each of those utterances score to represent that intent. Similarly, we are also representing here how accurately we are able to eliminate that other utterances provided for other intents are successfully being eliminated as a possible match for get account balance. Now, if you have any utterances that are in the false positive quadrant or the false negative quadrant, that's example of bad training. This will actually cause conflicts at runtime and create user frustration, and the platform actually gives you the ability to catch these issues upfront at design time and address and fix those issues before your users find them. This is unique to our platform and gives you a significant advantage and capability to be able to do proper training and modeling for your engine. The fundamental meaning-based natural language engine uses synonyms and patterns as a way to recognize the user's intent as well as entities. And these synonyms and patterns are provided at a platform level, but the developer of the bot is able to actually add more synonyms and patterns that are representative of their business based on unique terminology or unique ways in which the users might use the bot. The platform also offers a default dialog or a fallback dialog, which allows you to actually define a dialog that would be a fallback scenario in the event that the bot did not recognize the user's intent. We also give you the ability to actually do batch testing, where you can take your either user-defined or developer-defined utterances to run a batch test against your bot once you've provided training to see how good is your training and how accurately it's finding the intents. The platform also gives you the capability to actually run batch test against previously successful user utterances to ensure that as you make changes to your natural language model, you're not actually breaking things that were previously successful. Similarly, there are other settings that you can actually change in your natural language engine in the core platform. There are various thresholds that you can modify and make sure that you optimize the engine to your use case and your requirements. The next thing you can do is actually test utterances to see how the platform is doing. For example, when I type in an utterance like, how much money do I have? I can actually test and see whether the platform is accurately finding the intent match and the successful score for that particular intent match. Now let's try another utterance. For example, let's say if I say I'm interested in sending a payment today. The platform is actually providing scoring to tell you that this is the score that the machine learning model came up with to recognize this particular utterance and map it to the make a payment intent. Similarly, the fundamental meaning model came up with its own score to recognize the intent, and there was no match from the knowledge collection. And then finally, the ranker resolver algorithm that the core platform provides matches and finds the winning intent. Once you've done the test and train, you can enable the bot to live in many channels that the core platform offers. The enablement of the channels is quite simple. You can pick a channel that you're interested in and follow these configuration steps to enable the channel. The apps and agents view is where you can actually configure the BotKit SDK and various other capabilities that the platform has to offer. These SDKs give you a much more granular control of the platform and allow you to actually introduce custom logic and custom execution paths that the enterprise may be interested in. Finally, you can actually publish the changes you made to your bot configuration so that an administrator can approve them and push them into production. And the last step is to now analyze the performance of the bot. This is very important. This view allows you to basically, first of all, see how your bot is doing, if the platform is able to successfully match an intent, it will be tagged as an intent found. For each utterance that was successfully matched, for example this one, you can actually look at the details of the natural language engine scoring, and at that moment in time, what was the score, why was it matched, or why were the other options eliminated, and then why did we pick this particular winning intent. Also, you can actually look at the chat history to figure out what happened during this particular conversation, either before and after. Similarly, if the intent was not found, you have the ability to actually now train the bot to recognize the intent if it should have been found. For example, if I want to actually add this utterance to the training data because it should have been successfully recognized, I can actually first of all study why it failed to match. In this case, notice that even though the machine learning model gave a score for the get account balance intent, the score was too low for the engine to actually pick that as a winning intent. But maybe I should manually train in a supervised manner and add this utterance to the training data for get account balance. I've just added this particular utterance to the training data so that this utterance and various variations of this utterance will be successfully matched to this particular intent. I can retry the utterance and notice now that this particular utterance would be matched to my intent that I wanted to match to. You can also see that this particular utterance has now been tagged as trained, which means I have added this utterance to my training corpus. And similarly, I can do the same for other failed utterances and choose to train them or choose to leave them as valid failures. I can actually also go to the failed task tab to study why did the user abort a particular transaction, or why did a particular transaction fail. As an example, I can actually look at this particular task and look at the chat history to figure out what was the reason that the user aborted this particular task. Is it that the user got frustrated, the input was not recognized, did the API call fail, etc. So it gives me a great deal of visibility to also then go back and optimize my dialogue to improve the experience as well as improve the throughput that the bot is able to achieve. I can actually look at the performance of the bot as well on various parameters such as API calls, business logic, etc., so that I'm constantly keeping an eye on the performance of my bot. Lastly, the settings tab. There are various settings at the bot level that you can change. For example, things like the name of the bot, the logo, the welcome message can all be changed here. The languages that your bot supports. I can simply enable a language, for example, the Spanish language, and go through the steps of enabling it. I can invite other developers to co-develop this bot with me. I can define various bot variables that I can change as I take a particular bot configuration from one environment to the next. I can import and export my bot configuration from one environment to the other, or from this particular environment into a source control repository and back into the environment. I have also various IVR specific channel settings and various other advanced settings that I can change as well. And then finally, I have the ability to review all the logs of all the changes that I've made to my bot configuration. Lastly, I can go to the dashboard view to look at the performance of my bot. In this view, I can actually see how my bot is doing, how many tasks were performed, over a period of time, what are the peaks and the lows when my users are using the bot, what is the overall accuracy of my intent recognition. As an example, this particular bot has 94% accuracy and only 6% failure. What are the most popular tasks that my users are using, and which channel is most popular amongst the channels that I've enabled. So the bot builder provides complete end-to-end software development lifecycle and capabilities for you to quickly design, develop, and publish a bot with rapid speed and put it into production. Thank you.